Welcome to Math World. Today's class, let us learn few more properties of complex numbers along with some examples and problems. I have mentioned few properties in my last class. If I have two complex numbers z1 and z2, then if I want to find out z1 minus z2, then this is same as writing z1 plus minus of z2. Okay, if a complex number is written in terms of an ordered pair x1 comma y1 and z2 is x2 comma y2, then z1 minus z2 is same as writing x1 comma y1 minus x2 comma y2. It's same as writing x1 comma y1 plus minus of x2 comma minus of y2. This is same as writing x1 minus x2, the real part, comma y1 minus y2. Okay, this is in terms of an ordered pair. Okay, and if I want to calculate 1 by z, 1 by z, in fact this is same as z inverse. Okay, and I have obtained the equation in the sense I have obtained an ordered pair of z inverse. If z is written in terms of an ordered pair x comma y, then the z inverse is x by x square plus y square comma minus y by x square plus y square. The imaginary part is minus y by x square plus y square. This is 1 by z or z inverse. Okay, and suppose if you have two complex numbers z1 and z2, okay, and you want to calculate z1 by z2 in terms of an ordered pair, this is same as writing z1 into 1 by z2, or you can say z1 into z2 inverse. Okay, and provided this z2 is not equal to 0, then only you can find z1 by z2. So how is this? Let us write that z1 is in terms of an ordered pair x1 comma y1, and 1 by z2 or the z inverse is z2 inverse, right? So x2 by x2 square plus y2 square comma minus y2 by x2 square plus y2 square. This is z2 inverse, right? Now combine them. Since it's a product, you have to multiply x1 with this, x1 with this, then this with this, and this with this. Okay, I'll club and write x1 x2, okay, and this x2 square plus y2 square. In fact, I can directly write this with this, so with I comes out, so y1 y2 and minus x1 y2 plus y1 x2 divided by x2 square plus y2 square. You can separately multiply and combine, no problem. I have written directly. Okay, this is z1 by z2. Now suppose you want to calculate z1 plus z2 divided by z3. Okay, now this is same as writing z1 plus z2 into z3 inverse. Okay, this even can be written like this: z1 into z3 inverse plus z2 into z3 inverse. Always remember, this is when z3 is not equal to 0. So when I write it like this is same as writing z1 by z3 plus z2 by z3. Okay, depending on z1, z2, z3, you can do the calculation of this by using this expression or this or this. Okay, sometimes when z3 is just a constant, that means it's purely real, then you can directly go for this. If it is a complex number having both real and imaginary part, then you find z3 inverse and just go for the multiplication with z1 and z2, then add. Okay, whichever is easy, you can apply that depending on the complex numbers z1, z2, z3. One more thing, if z1 and z2, the product z1 z2 is equal to 0, then either z1 is 0 or z2 is 0, or both of them are 0. Either z1 is 0 or z2 is 0, or both of them are 0. Just see, suppose I have z1 z2 equal to 0. Okay, z1 into z2 is 0, and I assume that 1 is not 0, like z1 is not 0 and z1 is non-zero. Still the product is 0. I have to prove z2 is also equal to 0. Okay, when this z1 is not 0, it just implies that z1 inverse exists, right? When the complex number is not equal to 0, then its inverse exists. Now I have to prove z2 equal to 0, because z1 is not equal to 0, they have mentioned, and they have even said that z1 z2 is equal to 0. So now I have to prove z2 is equal to 0. Okay, z2, I can write this z2 as z2 into 1, right? Purely real number I am taking. Z2 can be written as z2 into 1. Now what is 1? Since I know that z1 is not 0 and z1 inverse exists, 1 I can replace it by z1 into z1 inverse, right? See, when this is true, then z1 inverse is 1. Inverse exists means the product is equal to 1, right? So I'm replacing 1 with this. Now I'll just take up these two. z2 into z1 is same as writing z1 into z2 into z1 inverse, right? Its complex number multiplication is commutative. So z1 z2 I can write it as z2 z1, I can write it as z1 z2. Now what is z1 z2? z1 z2 is 0. It is given, right? So 0 into z1 inverse. 0 into any complex number is 0. Therefore I'm getting z2 equal to 0. So from this you can observe one thing, that if two complex numbers z1 z2 are non-zero, then the product is z1 z2 is also non-zero. Okay, if the product is 0, then either z1 or z2 equal to 0, or both of them are equal to 0. Now let us look at few problems. first problem say reduce the complex number 1 minus I power 4 to a real number. So let me take z equal to 1 minus I. I'm taking this as my complex number. Okay, its power 4 is asked, so if I take z square, then it is 1 minus I whole square, which is same as writing 1 minus I into 1 minus I, right? Now do the multiplication. It's in fact a minus b whole square is a square minus b square minus 2i. So I'm getting minus 2i. If you want, you can write it like this, or you can directly use the formula. I square is minus 1, so I have written minus 1. Then minus 2i is minus 2i. So 1 1 will get cancelled, and z square I'm getting minus 2i. Now what I want z power 4. Z power 4 is same as writing z square into z square, right? So this is same as writing minus 2i into minus 2i. So this is equal to 4 I square, 4i square, which is same as minus 4. So you can write 1 minus I whole power 4 is minus 4, which is purely real. Next one, just show that 1 by z equal to z. It's easy. 1 by z is z inverse, right? So 1 by z can be written as 1 by z inverse. Okay, what I have to do is just multiply and divide it by z, so that this will be z divided by z into z inverse. Z into z inverse is 1, so the answer is just z. Next question, z1 is 2 plus I and z2 is 3 minus I. Find z1 by z2. Okay, z1 is 2 plus I, z1 by z2, 2 plus I divided by 3 minus I. What you have to do is I have to multiply and divide it by the conjugate of z2. Okay, that is 3 plus I divided by 3 plus I. It's a conjugate, not the inverse. Okay, keep it in mind. I'm just changing the sign, so that means it's a conjugate. Z inverse is different from the conjugate. So when I multiply and divide by the conjugate of the denominator, let us do the multiplication. 2 into 3 is 6, plus 2i plus 3i, I into I is I square, divided by a plus b into a minus b. So a square minus b square. So 6 I square is minus 1. So 6 plus 5i minus 1 divided by 9 minus 1, which is same as writing 5 plus 5i divided by 10. Right? I can take 5 outside, so that 1 plus 1i by 10, which is same as writing 1 plus I by 2, or you can even write 1 by 2 plus I by 2. In my next class, I'll be discussing vector representation of a complex number along with the modulus of a complex number. Thank you.